Hello to all my amazing, STEM students out there. Welcome back to this week's STEM lesson. Today, you're going to do a STEM lesson called Space Exploration with NASA and SpaceX. As you can see, we have NASA's logo here and SpaceX's logo here. We're going to learn a little bit about both of those organizations today. And as you can see from the picture, we're going to be studying rockets, astronauts, and how humans have figured out how to explore outer space. So way back, hundreds and hundreds of years, humans were always stuck on Earth. But they were, even though they were stuck on Earth, the unknown of outer space was so enthralling to them. So they wanted to know what was out there. And they studied and they researched outer space, but from Earth. And that is called astronomy. And astronomy is the study of the universe. Stars, planets, asteroids, the sun, Earth's atmosphere, all of that is considered astronomy. And astronomy is one of the oldest sciences in the world. Our calendar was even created by studying the stars in the sky. By using astronomy, they figured out that what 1 year is, and then how they figured out how they could split the year up into 12 months. Pretty cool. Humans have always been fascinated with the unknown of outer space, the big black vastness of outer space. They didn't know what was out there, so they wanted to learn about it. Here we have a 1,000-year-old Chinese star map. So an astronomer in China 1,000 years ago was studying the stars and was making maps. Here we have a 1,200-year-old Germanic map of the 7 planets. Now we know that there are 8 planets, and also Pluto, which is not a planet, but it still is a large rock that orbits the sun. And here we have Galileo, the most famous astronomer ever. He was the first one that took a telescope and pointed it up to the sky to study the moon and the stars. And here we have a 400-year-old drawing of the moon, where he was studying the surface of the moon and the different angles of the shadow. We have a crescent moon, a half moon, and he was doing that 400 years ago. But sadly, humans are kept on the ground by gravity, just like we learned last week. It's gravity or the down or weight that pulls things, that pulled your paper airplane down to the ground. And it's the same thing that kept humans on the ground for hundreds of thousands of years. So what did humans do? They invented rockets. And they kept improving them. They invented and tried it out and learned and made it better. So the first rocket that was ever used in the world were made by the Chinese. And they are called Chinese fire arrows. They took an arrow, back when they had bow and arrow, they would attach a bamboo tube filled with gunpowder, and they would light it, shoot the arrow, and the rocket would push the arrow forward even faster than they could ever shoot it. Then some 300 or 400 years later, there was a German scientist, a German doctor named Dr. Goddard's, who invented the very first rocket that used liquid fuel, liquid gasoline, in 1926. And then about 15 years later, they invented the German V2 missile. So they went from this shape here, small tank, to a very sleek rocket with a larger fuel tank. And this rocket, the V2 rocket, was the first rocket to ever reach outer space. But there were no astronauts on it, on that one. It was only the rocket, but it did reach all the way to outer space. And then now we have the most modern rocket that's ever been created, called the Falcon 9. And it was created by SpaceX, which is that company I was telling you about earlier. And you're going to learn more about this rocket later in the presentation. So as you can see, it went from the Chinese to the German rockets to now the very, very modern Falcon 9 rocket. So here we have a rocket read aloud. It's called Space Explorers Rockets. It's written by Jamie Fretlin Van Voorst. Here we go. So we have the table of contents here. We have 3 chapters, so let's get going. Again, it's called Space Explorers Rockets. Chapter 1, To the Moon. Think of the word rocket, and you probably think of power and speed. You may have played with a model rocket. Maybe you shot a bottle rocket on the 4th of July, which is a national holiday in the United States where they light off fireworks. But a space rocket is a different thing entirely. Rockets are powerful space delivery vehicles. They launch rovers to distant planets, little machines that are controlled and driven around like on Mars or the moon. They take artificial satellites into orbit like this, and those satellites are constantly rotating all around the world, and that's how we actually have cell phones, through these satellites. A rocket sent men to the moon, 3 astronauts. One shot the Hubble Space Telescope into space. Others launched the International Space Station piece by piece. Rockets deliver the astronauts who work there. And rockets still send some vehicles with supplies. It says, did you know rockets date back to the 13th century of China? They were used as fireworks and in battle, just like the rocket on the arrow. Chapter 2, How Rockets Work. A rocket is a complex piece of equipment. Its body is similar to an airplane's. So similar to the airplanes that we learned about last week. It is made from strong, lightweight metals. It has sensors. It has computers so that people on the ground can control the rocket when it's in outer space. That's amazing. It has a space for its payload, the thing it is bringing into space. That might be a rover, it might be a satellite, or it might be human astronauts. The biggest part is its engine, and you can see right here, there's all the mechanics of the engine, the 5 circular objects here, and that's where the fuel shoots out, and that's what pushes the rocket into the air. So what makes a rocket? Here are some important parts. The nose cone, which is the pointed top, that is there to help it become more aerodynamic so it can shoot through the air easier. We have the payload, which is where the astronauts are stationed when the rocket is taking off. The guidance system, that's how they control where it flies. The fuel tank, which is where all the liquid fuel is stored. And the engine, which is the part that takes the fuel and shoots it out of the bottom to boost the rocket off the ground. Have you ever let the air out of a balloon? What happens? The air goes one way, maybe to the left, and the balloon moves in the opposite direction, maybe to the right. A rocket works in the same way. A rocket engine burns fuel. In here, it's burning the fuel. It turns the fuel into hot gas. The engine shoots the gas down to the ground. That's what these flames are. So it's burning the fuel here, and it shoots the gas down to the ground. Then the gas blasts the rocket up into space. This is called jet propulsion. Most rockets weigh hundreds of tons at liftoff. Most of this weight is fuel. Rockets need lots of fuel to overcome Earth's gravity. They must travel 7 miles or 11 kilometers per second to enter orbit. So that's how fast it has to go to fight drag and to fight gravity that's trying to pull it back down to Earth. Chapter 3, stages in space. Most space rockets are multi-stage vehicles. This means that the rocket is split into parts or stages. Each part has an engine and fuel. When one stage uses up its fuel, it drops off. Then the next one takes over. But why? Once it uses up its fuel, a stage is useless. Its extra weight slows the rocket down. By dropping useless stages, the rocket can go faster. So on takeoff, here's the engine with all of the fuel stored right here. And once the fuel is gone, the spaceship doesn't need the engine anymore. So it's just useless weight. So it just gets rid of it. You'll see a demonstration on what that looks like later in the presentation. What happens to the stages that drop? Most burn up in the atmosphere, because when things fall through the atmosphere, it's super, super hot and they just disintegrate and they burn up, similar to this one right here. Maybe they fall down to Earth into the ocean, or some stages stay in space. They orbit Earth as space junk. Interesting. Rocket designs are always changing. Space rocket engineers, mechanical engineers are looking towards cheaper, reusable designs. They think someday rockets may carry people to a space station, almost like an airplane. Maybe one of those people will be you. That would be really cool. I wonder how many years it will take for us to get there. Probably quite a few. Let's go back to our presentation. Here we're going to learn about the history of space travel. And we're going to learn about the first human, who happened to be this man here in the picture. The first human in space, his name is Yuri Gagarin. He was a Russian astronaut. And here's a video of his launch that took him into space for the first time. You can see the gas shooting out, pushing the rocket off the ground. Super, super hot. Here's the engineers that are helping the rocket fly. And there it goes. It's fighting gravity, it's fighting drag, and it's shooting up into the air. This is in slow motion. The actual rocket would have gone a little bit faster. There it goes. As you can see, the flames are still shooting out of the bottom, pushing it up, and you can see the shadow here of the rocket going higher and higher and higher. And off Yuri Gagarin goes out into outer space, the first human to ever enter outer space. Next, we're going to learn about the first woman in space, and her name is Valentina Tereshkova. She is also from Russia, and she not only was the first woman in space, but she is the second youngest astronaut to ever be in space. And here's a little video that I'm going to play for you, and I will be reading it as it plays. She was almost abandoned in outer space. Nothing about Valentina's life hinted at her future greatness. Her father was a tractor driver and her mother worked in a textile factory making clothes. When she was 2, her father was killed in the army. She seemed destined to follow her mom's footsteps at the factory, except for one small interest. Valentina loved parachuting and paragliding. and saved up enough money from her factory job for her first jump. By the time she was 22, she had become an avid skydiver. Meanwhile, the space race was in full swing, and the space race was a race to get the first person in outer space between Russia and the United States. And as you just learned, Russia was the country that first got someone into outer space. Russia had launched the first man, Yuri Gagarin, into space, with America following closely behind, launching Alan Shepard a month later. A passionate thrill seeker, Valentina took a risk and applied to become an astronaut. Her parachuting experience far exceeded both male and female candidates alike. And she beat out over 400 applicants to pilot the Vostok 6 spacecraft on a solo mission. She was only 25 at the time. Training alongside men bigger and older than her had its difficulties. She begged her trainer to teach her the same risky procedures as her male counterparts. She once said, "A bird cannot fly with one wing only. Human spaceflight cannot develop any further without the active participation of women." On June 16, 1963, Vostok 6 made its way out of the atmosphere with Valentina behind the wheel. The first woman to travel to space, Valentina called out as the craft took off, "Hey, Sky, take off your hat. I'm on my way." She orbited the Earth an astounding 48 times in less than 3 days. That's more times than all the American astronauts who had flown before her combined. While on her trip, she noticed that her team forgot to pack her a toothbrush. But a missing toothbrush was the least of her worries. While in orbit, she realized that her capsule was mistakenly programmed to not return to Earth, and was orienting itself further and further away from Earth. So she had to act, or else she was never going to return to Earth. She was just going to float off into space forever. Without panicking, she calmly radioed ground control for assistance and skillfully navigated her return, safely ejecting herself from the capsule 4 miles above the surface. Despite Valentina's success, it took 19 years until another woman traveled to space. That would be Sally Ride, who you learned about yesterday. Valentina is the second youngest person to ever go into space, and remains the youngest woman ever to do so. Work hard and you will get there. Valentina Tereshkova. Very, very wise words from an amazing person. So, you might be thinking, why are we learning about space flight today? Well, let me give you a little background. In 2011, the United States government and NASA stopped sending astronauts into outer space. It was just getting too expensive, and this space ship here was just getting too old and too expensive to take care of. So a company called SpaceX has since then has designed and built their very own rockets. And we have a picture here of the Falcon 9 rocket that will be used for this, and that is today. Today. You're learning about this today, and this is something very cool is going to happen today. You can even watch it yourself later. Today, NASA and SpaceX are sending 2 astronauts into space for the first time in over 9 years on this Falcon 9 rocket that was invented and created and designed by SpaceX. The 2 astronauts are astronaut Doug Hurley on the left and astronaut Bob Behnken on the right. Now, what might that look like? Well, there was an amazing video that was created that will give you an idea of what today's launch will look like. Enjoy. So they go all the way to the top to climb into the payload.
Base launch trajectory countdown and pad is cleared. Go for launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, liftoff.
Now, earlier we talked in the book, in the read aloud, it talked about how the parts, when they're not needed anymore, they are released and let go in outer space. And here is an example of that.
Age separation confirmed.
And that is now space junk. Or it gets burned up in the atmosphere. And there's another one. So that one no longer has any fuel, so it's just extra weight that is not needed.
Separation confirmed.
This is the International Space Station that it is connecting to right now. They will then orbit the Earth, just like all the astronauts before them. They conduct amazing science experiments.
Separation visually confirmed.
And then here's what it will look like when their mission is over and they have to return to Earth. So they let go another part that is not needed anymore. Make their way through the atmosphere, which is release the parachute and crash down
Aids have been deployed.
into the ocean. Safely. All right. Well, guess what? Oh, it's playing again. That's not what I wanted. Now it's your turn to build your rocket. So you are going to be creating 3 or 4 rockets that look very similar to these ones, but they do not in any way have to look exactly like these. So materials that you are going to need when you become the space rocket engineer right now are you need 1 straw, you need 1 piece of paper, and you need tape or glue. As you can see, this rocket, these 2 rockets here, they used glue to put the fins on the rocket. You could also use tape. It's up to you. So, but you might be saying, well, I don't know how to do that. Well, here's a very cool video that shows you how to make the paper rockets that you're going to need today. Now, before I begin, I want you to know that this video moves pretty quickly, okay? And what I want you to do is I want you to press play, do 1 step at a time, and then I want you to pause the video. Complete that first step, then move on, hit play again, and move on to the next one. So here we go. Paper rockets. Right now, you should actually pause the video, gather your straw, your paper, your tape or glue, and a pair of scissors as well. So, step 1, you will need paper, straw, scissors, and tape. If you don't have those, pause the video and go get them. If you do, let's keep going. So first step, fold paper into fourths. All right, that was pretty quick. So I'm actually gonna go back and we're gonna do that one more time. So there's the full piece of paper. Step 1 is line up the corners. Step 2 is pull it up and line up the corners, and you're gonna make these rectangular shapes of paper. And then you cut along the lines. So just like he is, you're gonna cut along the line, and you're gonna end up with 4 separate rectangular pieces of paper. It says roll paper around the straw, but not too tight. That's very key. Don't roll it super tight around the straw. Watch how he does it. So he puts the straw right next to the paper, and then he rolls it around. And his tape is ready to go. Tape to hold in place. So tape on one end, tape the other end, and then tape the middle. Pinch one end to make the nose. Watch how he does this. Okay, so pinch the nose, then he's gonna grab a piece of tape and cover that hole. If you don't cover the hole, the air will just shoot out of the front of your rocket, and we don't want that, okay? Rocket air coming out of the front of your rocket will not make it fly very far. You have to close that hole. Tape it shut. Don't let any air out of the front of the rocket. Now it says cut out triangles to make fins, like we saw on the other rockets. And then tape them on the side of your rocket. And you see how he's taping the fins on the side that is open. Don't put the fins on the tip, okay? The fins go on the bottom. And as you can see, there's 4 fins. They're all facing in different directions. And there's a hole in the bottom. Don't cover that hole. This straw has to be able to go inside that hole, as you'll see next. Place rocket onto the straw and blow. Launch. Ready? Woo! And again. Woo! Turn this into a science project. Woo! That's what you're going to do next. The question is, what happens if you change the length of the rocket or the number of fins? So what you're going to do is you are going to create 3 or 4 different rockets. Then they're all going to look different. Some are going to be longer, some are going to be shorter, some are going to have different types of fins, different amount of fins, and then you're going to test all of them and see which one flies the farthest. All right. So if we go back, again, I want you to look at this image here. These are 4 examples of rockets. You can make the rockets look like these, or you can make your own design, okay? But each rocket needs to look a little bit different. But if you'll notice, they have very similar designs. There's a long tube with a pointed cone at the top that makes it aerodynamic. And then the fins are bigger or smaller, or some don't even have, maybe yours won't even have fins. Maybe yours will have circles or another type of design. And again, make 3 or 4 different rockets. Then what you're going to do is you're going to test your rockets as many times as you like, right? You can practice, launch it at different angles, and you just keep trying. And you learn, because it's all about the process. You launch, you see how far it went, then you pick it up and launch it a different way. See if it goes farther. See if it goes a shorter distance. And keep practicing launching your rockets until you're ready. And then what you're going to do is you're going to pick a starting launch area. You're going to test all 3 or 4 rockets, and you're going to see which rocket flies the farthest. Then you're going to, with your feet, you're going to measure how far your rocket flew. And just like the little feet in this image here, when you measure how far it went, make sure your toes touch the heel every time. And you're going to count 1, 2, 3, 4, starting from the starting spot. And you put how many feet your rocket flew. Then you take the first place winner, you take a picture, and you put the picture of your winning rocket right here, okay, in the picture frame. And then that's it. So again, as I said before, if you need some extra practice, or if you're confused on how to make your rocket, you can watch the video again. You can use these examples, or you can ask your parents for some support. I cannot wait to see what you create. Have fun, and I hope you enjoy being rocket scientists, being engineers. Thanks so much.